So today we're going to be talking about writing function rules from a situation or from a table. And so we want to be able to come up with a rule that takes our domain values and translates them into a certain range value that we want. So this is assignment number 4, and these should be your notes. So let's start with this problem. Bobby has a brother that is 2 years older than him. So we want to write a rule for his brother's age. So it's going to be b of x. So this means that we're going to find his brother's age in terms of an input value for x, where x is Bobby's age. So if we know Bobby's age, we want to be able to figure out what his brother's age is. So, but his brother's always 2 years older. So when Bobby was 2, his brother was 4. When Bobby was 5, his brother was 7. So we always take Bobby's age and add 2, and that's the rule. And so this means here that when Bobby was 6, we plug 6 in for x, and it's going to be 6 plus 2, which means his brother was 8. When Bobby was 14, his brother is 14 plus 2, which means his brother is 16. And when Bobby's 50, his brother is going to be 50 plus 2, which means his brother will be 52. And so this equation always gives us what Bobby's brother's age is if we know what Bobby's age is. Let's take a look at another example. Boston cooler at Zesto costs $4. So we're supposed to write a rule for the cost of buying X number of Boston coolers. So it's going to be C of X equals the number of Boston coolers times $4. So 4 times how many Boston coolers we buy. So if we buy 1, it's $4. If we buy 2, it's $8, and so on. And so the C represents the cost, and the X is how many Boston coolers we buy. So if we buy 2 Boston coolers, it's going to be 4 times 2, which is $8. If we buy 5 Boston coolers, it's 4 times 5, which is $20. And if we buy 7 Boston coolers, it's 4 not times X, but times 7, which is $28. All right, let's try another one. A taxi service charges $7 to sit in the cab and an additional $3 per mile. So the price of your cab ride, which is P of X, is going to always be $7. That's your beginning amount, $7 to sit in the cab, plus you have to pay $3 for every mile that you go. X represents the number of miles, so it's 7 plus 3x. And so for our first example here, that means you go 5 miles. In other words, we're going to replace the x with 5. So it's going to be 7 plus 3 times 5. 3 times 5 is 15, and 7 plus 15 is $22. So if you go 5 miles, your cab ride is going to cost $22. If you go 9 miles, it's going to be 7 plus 3 times 9. 3 times 9 is 27. So 7 plus 27 is $34 would be your output. And let's say you go 12 miles, then it's going to be 7 plus 3 times 12, and 3 times 12 is 36. So when you add 7 plus 36, you get $43. And so that's a function that describes that situation where X is the miles that we go and Y is the price of the cab ride. So let's take a look at some different situations. Here we don't have a situation, we just have a table of values. We have to figure out what are we doing to these numbers to get these numbers. What do we do to a 1 to get a -2, and a 5 to get a -10, and a 4 to get a -8, and a 3 to get a -6? It looks like it always doubles, but then the sign is always different. And so the function, or f of x, which is what we have here, to get those numbers, we always take whatever the x is and multiply it times -2. So -1 times -2 is -2. 5 times -2 is -10. 4 times -2 is -8. And 3 times -2 is -6. So then we want to figure out what is f of 10. Well, f of 10 means we're going to replace the x with a 10. So instead of -2 times x, it's -2 times 10, which is -20. Then if f of x is 22, So that means we get a 22 over here. We want to figure out what does y have to be, or what does x have to be, so that 22 comes out. What is x? So in other words, the f of x here is 22. And that equals negative 2 times x. So now we want to figure out what x is. We're going to have to undo multiplying by negative 2 by dividing by negative 2. So the negative 2's will cancel, and we'll have that x equals 22 divided by negative 2, which is negative 11. All right, let's move on. Fifth example here. Same thing. We're trying to write an equation for a table. Here's our domain values. Here's our range values. 1 becomes a negative 6, 7 becomes a 0, 10 becomes a 3, and negative 2 becomes a negative 9. So we might have to think about this a little bit, but after a while we should recognize that whenever we stick in an x, we subtract 7 from it. 1 minus 7 is negative 6, 7 minus 7 is 0, 10 minus 7 is 3, negative 2 minus 7 is negative 9. So our equation is f of x equals x minus 7. And if we let 15 be our input, it's going to be f of 15, we can write it like this, is going to equal 15 minus 7, and 15 minus 7 is 8. But if it's written like this, if f of x gives you a 5, that means there's an x value that gives you a 5 back out. So that means the f of x is 5, and we can write our equation as 5 equals x minus 7. We're just replacing the f of x with a 5 here. And so we want to figure out what x is. We want to get the x by itself. We're going to add 7 to both sides so that x is 12. All right, one more example with a table here. 4 becomes 16, 8 becomes 12, 2 becomes 18, 15 becomes 5. So this is a little bit more difficult, but think about it like this. Let's say something that you buy costs 20 bucks. You give them $4, your change is 16. If it costs 20 bucks and you give them $8, your change is 12. If you give them $2, your change is $18. And if you give them $15, your change is going to be $5. So f of x, our equation, is going to be 20, which is how much you give them, minus how much something cost, which is what the x must be. 20 minus 4 is 16. 20 minus 8 is 12. 20 minus 2 is 18. 20 minus 15 is 5. So here's our equation. And if I want to find f of 17, I'm just going to replace the x with a 17. And 20 minus 17 is 3. If f of x is 6, then I'm going to replace the f of x here with a 6, and it's going to be 6 equals 20 minus x. So to figure out what x is, I would subtract 20 from both sides. So this is negative 14 equals negative x. But then if I divide everything by negative 1, positive x will equal positive 14. And that makes sense because if I take 20 minus 14, what I get is 6. Let's try another example here. Take a look at this one. 3 becomes a 5, 5 becomes a 9, 10 becomes a 19, and negative 4 becomes a negative 9. Might be a good idea for you to just pause your computer, see if you can figure this one out before I give you what the answer is. So if you've done that, hopefully you were able to figure out that if you take these x values here and double them, so you multiply them by 2, subtract 1, you always get the numbers on the right. So 3 times 2 is 6, but 6 minus 1 is 5. 5 times 2 is 10, but 10 minus 1 is 9. 10 times 2 is 20, but 20 minus 1 is 19. And negative 4 times 2 is negative 8, and negative 8 minus 1 is negative 9. So if I wanted to stick in 7, f of 7 is simply going to be 2 times 7 minus 1. Well, that's 14 minus 1, which is 13. And then if f of x is 5, then I'm going to replace the f of x with 5, and that equals 2x minus 1. And you can kind of see we already have this one here. To solve this equation, I would add 1 to both sides, so 6 becomes 2x, and if I divide by 2, x is 3, which means if I plug in a 3, 5 is what I get back out. All right, last one here. This is kind of a tough one. See what you can, if you can figure out how do you change a 2 to a 4, a 3 to a 9, a 4 to a 16, and a 5 to a 25. You can pause the video, and if you've done that, hopefully you're able to figure out that f of x equals whatever x is squared. You just multiply it times itself. 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. So if I plug in a 10 here, f of 10 is simply going to be 10 squared, which is 100. And then if f of x is 64, then I'm going to have 64 equals x squared. And we really haven't talked about this yet, but we would take the square root of both sides to get the x by itself, and the square root of 64 is 8, which makes sense because if we take 8 and square it, we get 64. All right. Now take a look at this one. 3 stays a 3, but negative 2 becomes a positive 2. 0 stays a 0, 5 stays a 5, but negative 9 becomes a positive 9. So everything is becoming positive over here. So hopefully you know that f of x is going to equal the absolute value of x. Because there, when we want the absolute value, that's how far away it is from 0. So we just take the absolute value of each of those numbers. So when I plug in negative 5, it's going to be the absolute value of negative 5, which is just 5. And then if f of x is 9, then I'll have something like this. F of x is 9, so 9 equals the absolute value of x, which means x could be two things. X could be 9, or x could be negative 9. 9 or negative 9. And the reason why it's both is because I can plug in a 9 or a negative 9 in here for x, and they both will give me a positive 9 back out. All right, so that is today's video. Good luck with your homework assignment, and we will see you tomorrow in class.